Hello, good morning everyone. I hope you all are fine. Today we'll discuss about the class level maths. In the earlier class we discussed about the sets, the definition of sets and type of sets. Today we'll discuss the more things on sets. Let's see what are the more things on sets. First things we'll discuss about the Venn diagram, and second things the operations of sets. And on operations of sets only one thing we'll discuss, that is the union of sets. Okay, let's see what is the Venn diagram. Venn diagram. Venn diagram is most of the most of the relations between the sets are represented by the diagrams, and it was introduced by the English mathematician. What is the name? Mathematician John Venn. Okay, John Venn, born on 1834 and died on 1883. Okay, as he introduced, and he is used to represent the relationships amongst the sets by diagrams. On that issues, the diagrams are named as Venn diagrams. Okay, and generally we use rectangles. Two shapes are used. One is rectangles, another is simple closed curve or circles. Rectangles are used for universal sets, and these are used for subsets of the subsets of the universal set. Okay, and the elements of sets are written within the, suppose a set is there. What is the set? 1, 2. These are the elements 1, 2, 3, and these are written within the circles. This 1, this 2, this 3 elements are written within the circles. As for example, you can take, so z is equal to 1, 2, 3, 4, 5. This is the natural numbers, and a is said is what? 1, 2, 3. Okay. Now how it represents this? This is the universal set, and on that universal set a is the subset, and the elements are about 1, 2, is 3. So this is the representation of sets. Okay, or also you can say the relationship between the sets represents by shapes or diagrams, and these are known as Venn diagrams. Clear? Next we will discuss about the operations on sets. We will discuss the operations on the sets. Operations on sets. And in operations set, first thing is we will discuss the union of sets. What is the union of sets? Suppose two sets A and B, two non-empty sets A and B we are taking, and the union of two non-empty sets is denoted by A. You read as A union B. Okay, and how to define A union B? A union B is defined as what? A union B is nothing but a set, consists of all the elements of A and the elements of B, but the common elements only once you have to write. Only once you have to write. Let's see the example. That is, A is equal to 1, 2, 3, 4, 5, 6, and B is equal to what? 3, 5, 6, 7, 8. So what will be A union B? A union B is what? 1, 2, 3, 4, 5, 6, 7, 8. So all the elements consists of all the elements of A and B, and the common elements. This is common elements. 3 is common element, 5 is common element, 6 is common elements. They are written only once. 3 only once, 5 only once, 6 only once you have to write. That is the union. So how to define, how to write that things? See, let A and B are two sets. The union of A and B is denoted by A union B and defined as A union B is equal to what? X such that X belongs to A or X belongs to B. This is the definition of the union. An example, how you can take example? Already gave the example. Example, we can say A is equal to 1, 3, 5, 7. B is equal to 2, 4, 6, 8. So A union B is equal to what? 1, 2, 3, 4, 5, 6, 7, 8. This is the A union B. This is the operations of union. Operations of sets as union. Okay. Now how can you define this? Or you find out the relations on these things with the help of the Venn diagrams. Let's see Venn diagrams. A union B. If we see the Venn diagrams, this is A, this is A, this is B, this is B. If there is no common elements, that is disjoint, not joint. Okay. So this will be the A union. This is A union B. If something is common, this is A, this is B, this part is common, then common part only once it will come. That is A union B, the shaded part. Okay, represents by the Venn diagrams also, A union B in this way. Okay. Next, it may be like that. This is A, and B. This is B. B subset of A. Then that time what will get? A union B. The complete A. So A union B is equal to what? A. And next it may be like that. This is B, this is A. In this case, A is subset of B. In case of A is subset of B, then what will get? The complete elements A union B is equal to what? Nothing but B. These are the representation of Venn diagrams, representation of the unions by Venn diagrams. Okay? Clear? Union clear? Now see some properties. Properties is what? Properties of union. First one is what? What you can say first one? A union B is equal to B union A. This known as commutative. Already got 1 plus 2 is equal to in earlier class in class 5, 6. In class 5, 6, what do we get? 1 plus 2 is equal to 2 plus 1. This is known as addition, commutative on addition. Okay, this commutative on the union sets. Next is what? As for example, we can take this is 1, 2, 3, and B is what? 2, 4, 6. So A union B is equal to what? What you can say? 1, 2, 3, 4, 6. And B union A is what? What you can say? 1, 2, 3, 4, 6. So what you can say here? A union B is equal to B union A. So with the help of the examples, you can prove the properties. Okay. Second property is what? A union B union C is equal to what? If we take 3 sets, A union B union C, this is known as associative law. Okay, this is known as associative law. Now see, if A union B, 3 sets we take A, this is A, this is B, and this is C. What will be A union B? A union B is, this is A union B, this is A union B, and this is what? With this A union B, it is says C. So what will get? A union B already this part, again C is, this is C. So A, B, C. This is what we can say. A union B union C. Okay. And this is the right. This is what? A. This is the left hand side. Right hand side is what? A union B union C. This is A. This is B. This is C. So B union C. What is B union C? This is B union C. This is B union C. And this is A. This is B. This is C. B union C, already this part B union C, and again union, this part will also come. So what you can say? A union B union C. So if we compare these two, what you can say? A union B union C is equal to what? A union B union C. So with the help of the Venn diagrams also you can prove the properties. So this second property is associative law. First property is commutative law. Second property is associative law. Third property is what? What is the third property? A union phi is equal to A. Phi is what? Empty set. If we take the union of any set with the empty set, is this is called identity law. identity law. Next is what? Union of itself is the set itself. This is called idempotent law. Potent law. Okay. Next, if we take the union with the universal set, then universal set, law of universal set, law of U. And next is what? Already proved this one. What is the if A subset of B, then A union B is equal to what? B, and B subset of A and B subset of A, then A union B is equal to what? A. So this is the properties. These are the properties of the union. I think you understand all these things, or you can try with the help of some examples, then it will be clear to you. Okay, so have a nice day. Thank you.